Hiya to in today's video we're going to be looking at arrays. This is actually the first thing that we focused on in our brand new unit on multiplication and division. Before we get started, an array is when you have objects that are arranged in equal rows and columns. Just need to remember that a row is horizontal, goes this way, and columns are vertical. Okay, I've got some cubes here and I want to arrange them into an array. Let's see. The first thing I'm going to do is I'm going to count up my whole. How many cubes have I got all together? 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 cubes altogether. I'm actually just going to write that down. 8 is my whole. I want to arrange these in an array. That means that they need to be in equal rows and equal columns. Let me think. I'm actually going to just group them into twos. Let's see if that works first. 2, 2, 2. 2. That's equal. I've shared out 8 equally. Let's see if I can put that into an array now. 1, 2, 1, 2, 1, 2, 1, 2. Yes, I've made an array. I have got the same number of cubes in each row and in each column. Let me just spread that out and make it nice and neat, like an array would be. Let's have a look at what we've actually got here. I'm going to focus on my rows first. Let me first circle the rows. I can see here that I've got 2 groups of, well, let me see, how many are in each group? 1, 2, 3, 4. 1, 2, 3, 4. I've got 2 groups of 4. I'm actually going to add the word equal in there. I've got 2 equal groups of 4. That means I've got 2 groups and there are 4 cubes in each group. There's actually also another way that I can look at this. I've looked at my rows, but what about if I look the other way? I might change my pen color here just so you can see it. I've looked at my rows. I'm going to look at my columns. Let's have a look. That's going vertically. I've got 1, 2, 3, 4. That's quite interesting. So yes, I've got 2 equal groups of 4, but I've also got, let me write it up here, 4, because I had 1, 2, 3, 4 equal groups of, well, how many are in each group? I've got 1, 2 in my first group, 1, 2 in my second group, 1, 2 in my third group, and 1, 2 in my fourth group. I've got 4 groups of 2. Wow, that's quite interesting. I've got 2 groups of 4, if I look at my rows, and 4 groups of 2, if I look at my columns. There's actually another way I can write these. 2 equal groups of 4 is the exact same thing as me writing, let's do it here. 2 multiplied by 4. In the same way, 4 groups of 2 is the exact same thing as me writing 4 multiplied by 2. The amount of groups multiplied by how many are in each group. Both of these will give me my answer. If I look at my 2 equal groups of 4, my rows, let me count how many I've got all together. I've got 1, 2, 3, 4, 5, 6, 7, 8. 2 times 4 equals 8. That's the whole. How many cubes have I got all together? What about this one then? If I'm looking at my columns, I've got 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to write that again. 4 multiplied by 2 is 8. Very interesting. My whole stays the same. There's actually another thing I've noticed here. I'm just going to move all of this and write it again just so you can see it. I had 2 multiplied by 4, which gave me 8. And I also have 4 multiplied by 2, which gives me 8. Notice how my whole always stays the same. You might have noticed a pattern here. 2, 4, 4, 2. What I've done here is I've swapped my parts around. I've swapped the number of groups by how many in each group. And that gives me my whole. I've swapped my parts around. You might remember from addition, we call that commutative law or commutativity. And that tells us that we can swap our parts around and still get the same whole. Just like in addition, the same as in multiplication. I can swap my parts around and still get the same whole. Thinking about that, let's have a go at doing another one. What if I was given this equation? There are a few ways I can work this out. I could either roll my 3s or roll my 5s, or if I want to look at this in an array and represent it, I'm actually saying there are 3 groups with 5 in each group. Let's make that. Let's make our 3 groups. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. I've made my 3 groups of 5, but this isn't an array yet. Let me arrange it into one. I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just going to straighten that all out. Okay. Right. You can see here, I've got my 3 groups with 5 in each group. I'm going to circle them just so it's really clear. 1, 2, 3, 4. Oh, whoops, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. 3 groups of 5 is the same as saying 3 times 5. I'm actually going to count them all up to find out my whole. You can count with me if you want. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. 11, 12, 13, 14, 15. 3 times 5 is 15. And in the same way, using commutative law, if they gave me this equation, I know the answer is still 15 because I've just swapped my parts around. 5 times 3 equals 15 tells me I'm now looking here. 1, 2, 3, 4, 5. I've got 5 equal groups with 3 in each group, and that still gives me 15. You might already see that because I didn't add any deans, I didn't take any deans away. There's another way you can do this without drawing an array. You could just say 3 times 5 equals, well, I can roll my 5s, and I'm going to stop when I reach 3. 0, 5, 10, 15. Oh, 3 times 5 is 15. You might also know your 3 times table, and you could have done 0, 3, 6, 9, 12, 15, and stop at 5. 3 times 5 is 15. And that is how you solve arrays. I'm going to give you one to try now. I'd love if you posted yours to Seesaw so I could see exactly how you do it. I'm going to give you this equation here. See if you can have a go at drawing your array, stating how many groups of what you've got, and then writing out the answer to this equation and another equation that you could make using this. Okay. That's it for this video, but see you next time.